Hello my dear lovely students, today we are entering into the physics, and the first gate of the physics is known as the principle of the classical mechanics, and it starts with the kinematics part. And first, in the case of the finite kinematics, we'll first study what is the rest of the object, when the object is called at rest and when the object is called at motion. First concept is called as the rest and motion, and this rest and motion is basically concluded or basically depends upon the concept of frame of reference. And when you will say that the object is at rest and object is at motion, then that is known as that is derived, or that concept is from the concept of frame of reference. Then we'll go to the, as listed here, the concept of distance and displacement. What is distance and what is displacement? Then go to the average speed and the instantaneous speed. What is the average speed and what is instantaneous speed? Then average velocity and instantaneous velocity. Then average acceleration and instantaneous acceleration. Then we'll go to the equations of motions, and we'll learn how the particle behave under the motion and how it is governed the motion, means how it behaves as well. Then first we'll know the concept of frame of reference. What is the frame of reference? Suppose you are saying that a bike is moving with 60 km/h. How you are knowing that bike is moving with 60 km/h? Means you are near the road, and you are looking at the bike and you are seeing that the bike is moving at 60 km/h. And the vehicle rider also saying that I am riding on the highway and I am seeing that the tree is moving backward to me with 60 km/h. Then the biker is saying that yes, I am moving 60 km/h. Or you can say the odometer is giving the reading that bike is moving at 60 km/h. How the odometer is looking, or how the odometer is knowing that bike is moving at 60 km/h? It is looking at the road. It is looking at the rotation of the wheel, the front wheel. The wheel is related to the road, and then the odometer is saying that, well, the road is moving 60 km/h backward to me. Then the bike is moving 60 km/h to the forward direction. This is known as the concept of frame of reference. You are inside a train. You must have you should have experience that when two trains is close to each other and near the platform, and you are sitting near your window, and suddenly you see that one of the train is moving. You can assure that my train is moving, or that train is moving. You can say that one of these train is moving. This is called as the frame of reference. You are sitting inside a train, and you are seeing to that train, and that train is moving backward. You can say, yeah, that train is moving to the backward direction, or my train is moving to the forward direction. And you are seeing constant electric pole, which is rest to the earth frame of reference. Then you are saying that, well, my train is at rest, and that train is moving backward to my direction, backward to me. Or if you are seeing that the pole is moving backward to you, then you can say that my train is moving forward direction, or my train has left this platform. This is called as the concept of frame of reference. This is basically related to the concept of relativity derived by Albert Einstein. This is the concept of Newtonian relativity. When you will go to the modern relativity, you will see the time dilation and the space contraction effect. We will learn it later. Okay, so this is the frame of reference, and from this concept, motion, the rest and motion is derived. So if you are saying that object is in motion, then you have to say that the object is moving with this frame of reference, or with respect to this frame of reference, with this speed. You are moving, suppose you are in a car, and the car is moving 60 km/h into the front of your direction, and another car is moving backward to you with 120 km/h. You observe that the car is moving 120 km/h, and you were saying, well, my father, that car is going 120 km/h. Or your father said, no, dude, that car is moving 60 km/h with respect to you. with respect to the Earth frame of reference. With respect to you, it is 120, but with respect to Earth, it is moving at 60 km per hour backward in the direction. This is called the Newtonian relativity. In the concept of Newtonian relativity, when you are at rest and you are at rest with Earth frame of reference and you are observing something, that is called the absolute velocity with Earth frame of reference. And when you are moving in one direction and another one is moving backward to you, then there is the addition of the velocity happens, that if you are moving in 30 km per hour, another one is moving 50 km per hour backward direction, the net effective velocity to you gives us the 80 km per hour. If you are moving 30 km per hour in this direction, another car is overtaking you and is moving 50 km per hour, and you are observing that, and your effective velocity will give you that car is moving 20 km per hour. This is called the Newtonian relativity, and with this concept, the rest and motion is derived. In case of Newtonian relativity, if you go to the advanced mechanics, then there you can see the Einstein concept, time dilation, length contraction as well. We are not going to that right now. Okay, so what is rest? Rest means to any frame of earth. Actually, to be honest, there is no absolute rest in this universe. You cannot say that this thing is absolutely rest with respect to some frame of reference. You cannot say that, because to which frame of reference you are saying, that frame of reference is not guaranteed to be at rest with some hyper frame of reference. Is, there is no concept of absolute rest in the universe, mind it. And you can say, well, that object is at rest with respect to me or with respect to my frame of reference, because after some, I measured that the distance between here to there, after a certain time, then no change in the distance, that, and after a long time also it will not change this direction. Oh, we are not sure about future. So you can say within some interval of time, this object does not change its place with respect to me. So I can say that object is at rest. Okay, so this is the it should be obvious to you that rest and motion, this is the real concept of here. And another one is called as the distance and displacement. This is very important topic in your mechanics and in the case of the kinematics. What is distance and what is displacement? Actually, this is a scalar quantity and this is a vector quantity. This is the very big difference between these two things, that this distance is a scalar quantity. We have learned what is scalar and vector in the previous chapter. Distance is called as the scalar and the displacement is called as the vector quantity. Well, the distance, I'm drawing a diagram here to let you understand. Suppose this is a point A, this is a point B. Suppose a guy traveled from here to here with couple of ways he tried, like this, suppose, and another one smart guy approached its a straight direction, a straight path. Another one take a crazy way and then reached it. Is there? So now my question is, how much distance is traveled by boy A? Suppose this is B and this is C. How much distance is traveled by the guy A and how much distance is traveled by the guy B and the C respectively? How can you answer it? If you were taking the reading of the bike or the odometer of the bike or the vehicle, whatever he is riding, then you can see the distance traveled by A is maybe, I don't know, maybe 60 meter, and travel B by is equal to 30 meter, and travel the C taken the path, that's equal to 80 meter, whatever. So this is called as the distance. So if someone asks you what is the distance between A and B, then you need to say that which according to whom you are having the answer, either according to the guy A or according to the guy C. If you are taking the concept of if you are taking or trusting on the guy A, then you can say that the distance between A to B is equal to 60 meter. If you are trusting on the guy C, you can say, well, the distance between A to B is 80 meters. And if you are smart enough, then you will just go from A to B and put a rope directly measure to the shortest distance between A and B. Then you can say, well, you can take any approach, you can take any way, then this will give you at 60 meter or 80 meter, whatever the distance you have, but the absolute shortest distance is equal to 30 meter. I have measured that. This absolute shortest distance is nothing but called as the displacement. So the displacement is nothing but the minimum distance measured from minimum distance, or the minimum or the length of the straight line, connecting straight line from any 2 point, whoops, what happened, A to B, I don't know what is going on with this, from A to B, the minimum distance, that is the minimum length of the straight line of A to B is the displacement here. So displacement is the shortest distance. Displacement is the shortest distance between any 2 point. So displacement is the shortest distance between any two. Remember it in mind, and this is a vector quantity. This is denoted, some professors say it as D, some say it as H, some many later you can check, and the convention, many of the physicists or the author use letter H to represent it, and it is given as an arrow mark on it. This is called as the displacement. So displacement is a directional quantity, and you can say this is a vector. You can say that if it is a vector, then it should have a direction to which side it belongs. If you are measuring from A to B, then it goes as this direction. If you are measuring from B to A, then this is known as A direction. It means this side. So between any 2 point A and B, you can say the direction. If you are measuring from A to B, then it is directed as this. If you are measuring from B to A, this is directed as this. It sometimes sometimes behaves as a position vector. Position vector means if this is a coordinate system and this is any point, let it be A, and this is the origin here, O, and suppose you are measuring from position of A, and you can give like this. So this sometimes behave as the position vector. If you are measuring from A to B, then this is the vector mark. If you are measuring from B to A, then this is this sign. This is all about the distance and displacement. Okay, so now we will talk about average speed and instantaneous speed. So what is average and instantaneous speed? Oh, well, what is speed first? First we need to know what is speed, then we will go for average speed. Okay, so first we will know what is speed. Suppose we'll take that example. Suppose guy A and guy B travel this distance and this distance. Suppose one took this road, suppose someone take this road and covered 80 meters by traveling from A to B. So what is speed here? Speed is nothing but the distance travel, I mean the total distance travel. Total, I should write here total distance travel by any path over the total time taken. It should be obvious to you that speed is of two types, whether it is average speed or instantaneous speed. I have written here the average speed. So the average speed is equal to the total distance covered by the vehicle over the total time taken. Suppose you are traveling from your school to your room, and on the way there is a hump, and you changed your gear, shifted it to gear number 1, then you step off it and then accelerate your vehicle up to 60 km, then another hump comes from you, then you apply your brake and reduce to your speed of 20 km per hour. Then you again rise up to the 60 km and then you reach your home. Then your graph, sometimes I should introduce you to the graph. A graph looks like from the school you started accelerating and take 60 km per hour, then you took, then suddenly you go on with the 60 km per hour, then humps came, then you comes to down to 20, then you take a straight line, and after some distance you accelerate again. That's like a crazy path. The total distance travel is covered by many type of speed. 0 to 60. Just every point, then you continue at 60, then you come to down, means decelerate your vehicle, then whatever the crazy speed you may have, then the total average speed is equal to the total distance you have covered, whatever the distance your odometer is showing on your vehicle. Suppose it is 16 km or 15 km. Well, to cover 15 km you took, suppose, 3 minutes. So 3 minute time is taken to cover 15 km. What is your speed? Total distance covered over the total time taken. So 15 km over 3 minutes equal to 1 over 3 minutes. Okay, we will go with 3 minutes as well. No critical in mathematics. That's equal to 5 km per minute. This is your speed. So if you are someone asking to which speed you came from your coaching center or your school to your home, then you can say that is 5 km per minute. Then we are going to talk about, this is the concept of the average speed. Then we are going to talk about instantaneous speed. Now you are riding on your road and your speedometer is showing that you are driving on 60 km per hour. That is the instantaneous speed. At any instant when you are driving and if you are interested, I'm driving now, I'm interested to know my velocity. What is my velocity? Then my velocity is equal to the exact velocity at some time. So how to measure that? This is nothing but the exact velocity means, what exact velocity I'm explaining here. I took some little distance that is known as delta t, some little time that is known as delta t, and within this time I cover, suppose, delta s distance. So my distance travel in the little time difference delta t. So the instantaneous speed equals to the delta s over delta t, where provided delta t tends to 0. So limit delta t tends to 0. This means, so I can broadly write it. I should write it here. So instantaneous speed equals to limit when time interval tends to 0, means for a very little time, your delta s over delta t. Suppose for 0.3 second I open my stopwatch. Within 0.3 second I observe that I travel 1 meter. So I can say 3 meter per second, approximately 3 meter per second. I can say that I am traveling approximately 3 meter per second speed, and for the accuracy of the instantaneous speed depends upon how much shortest time you have taken, how much your observation time short is. So limit within a concept that the observation time should be minimum and the travel distance at that interval of time over that observation time is known as the instantaneous speed. So instantaneous speed is practical. You can say instantaneous speed is nothing but the speed shown by your vehicle at any instant of time is known as the instantaneous speed. Then that is called the next topic is your average velocity and instantaneous velocity. Well, average velocity, what is velocity first, and what is the difference between velocity and speed? This is very close term and there is very little difference here. the vector form of the speed is known as the velocity. If the direction or direction term is added to the speed, then that will change to velocity. We are taking an example. Suppose one particle is traveling from A to B, exactly the same example we were taking, and this is taking a crazy path from A to B, and one other particle is coming with the shortest distance. So average velocity is equal to the total displacement d total over the total time taken, t total. This is called as the average velocity, and you should have an arrow mark here. That the total displacement travel from A to B with the total time taken. If you are interested from A to B, then you will go with the arrow mark this, and if you are interested from B to A, then you will go with the arrow mark of this. This is known as the average. This is known as the velocity first. The velocity is equal to when you are dividing distance simply s, you are dividing distance with the time, then that gives you speed, and while you are dividing displacement with an arrow mark over s with the time, then that gives you displacement. That gives you velocity. So velocity is nothing but the vector form of the speed is known as the velocity. And remember one thing, speed does not give you the direction. You cannot say this vehicle is moving to this word or that word, whereas remember, the velocity gives you the direction. Velocity confirms you that this particle is right now is moving at this magnitude with this direction. Suppose I am interested to moving this particle velocity at here with the instantaneous velocity right now. How can I represent the instantaneous velocity? Simply exactly that term, when the instantaneous speed is associated with a direction, that is called as the instantaneous velocity. I am taking a little tiny time displacement or the little tiny time interval within here, and I measure that this particle displaced from a delta s vector with the time of delta t. Then what is the term called as the displacement? The displacement is there delta s and delta t. Now at this situation, the speed will not give you the direction, but the displacement give you the direction as well. At this point, you can see from here to here, you can put a straight line, and this will give velocity will give you this direction. This is called tangential direction. Suppose you are traveling. Suppose a vehicle is going on a circular path, and you are interested to measuring its velocity at this position. Then you can say that this is its velocity at this point is this much. Suppose it is 30 km per hour, and with this direction. So velocity gives you the direction, but the speed does not. If you are interested to the direction at any situation, then go with the velocity. It will help you much. Then called as the acceleration. Exactly, what is acceleration? Suppose you are speeding of your bike, or you are applying the brake of your bike. There are two types of acceleration: positive acceleration or negative acceleration. Positive acceleration called acceleration, but the negative acceleration sometimes is called the deceleration. So the instantaneous acceleration and average acceleration is, you can see, if you were traveling within a bike and your bike is speeding up like this, so you can say with the time 0 acceleration and time graph. With the time 0, if your vehicle is at here and is at time t, your vehicle is at here, and after little tiny it's a huge time difference, you can say, it took the acceleration from let it be 10 and to 60. So your average acceleration, A average, gives you 60 minus 10 over, suppose it is 5, 0 to 5 second, is 5, this gives you 50 over 5 is equal to 10 meter per second square. This is its dimension, or the unit of acceleration is called as the meter over second square, and the average acceleration is nothing but the change in acceleration over the time taken. So everything here is related to the same concept. Average means total change over the total time taken, and instantaneous means when this time interval is tends to 0, that will give you the shortest time, the absolute instantaneous acceleration or the exact acceleration at any point, that will give you, then that term is called as the instantaneous term. So everything, these three or four terms is related with this concept, and acceleration also a vector quantity, and when this is the change in velocity, if you are interested in the change in velocity, then you can say the change in velocity, if you are interested with velocity, then that will give you the acceleration, and the speed is not associated with acceleration because acceleration is a vector quantity. You cannot derive the change in the speed is equal to acceleration. Means if you are speeding up your bike and you are telling that I am interested with my speed, then you cannot say that I have an acceleration. Means acceleration is always a vector quantity. Then if you are saying that I have an acceleration, then you must have to go with the velocity. So acceleration is always associated with velocity. There is no relation of acceleration with the speed. Because remember one thing, acceleration is a vector quantity. It is denoted as a vector, a small a vector. This is called as the acceleration term. So two basic, before conclude, I should go with the two basic idea. One is instantaneous, another is average. What is instantaneous? If you are saying something with a very instant of time, then that is known as the instantaneous term. And if you are interested in the total time, total coverage of time, whatever time I am traveling with, the entire time period if I am observing, then you can say that is the average term. But instantaneous, in the term of the instantaneous, it gives you the exact value right on the time. This is the difference. And one more basic little misconfusion arises in the distance and displacement. Remember one thing, distance is covered by any crazy way, but the displacement is the shortest distance between the 2 points. Suppose you are going from your home to your school, you are connecting a thread and making it detach. That length of the thread, and you can say connecting it to the 2 point with a straight line, the length of the straight line is called as the displacement here. And it is a vector quantity. If you are observing from your home to school, then that is goes to that direction, and if you are observing from your school to your home, then it goes in this direction. This is the one thing. And one thing is the speed and velocity, exactly same. If you are interested with the distance, then dividing with respect to time, then that gives you speed. And if you are interested with the velocity, you should have to go with the displacement, then dividing with the displacement, that gives you velocity term. So at the next video we'll solve the equation of the motion, and we'll talk little thing about the free fall, because free fall is going on the projectile motion. The next video will be on projectile motion. So the equation of the motion will be our next topic. So that's it for today. Thank you. Thanks for watching. If you are liking my video, please share and subscribe, and don't forget to give thumbs up, and don't forget to give a comment below if I am saying something wrong, my mistake, I am saying something wrong, or even not understanding anything. Tell me, I will make you another video and I will describe you again and again. Thanks for watching.